Alright, let's talk about proofs using coordinate geometry. So I have a trapezoid drawn there, and I need to find the midpoint of the mid-segment. So if you think of mid-segment here, that's the middle point part of my trapezoid, and I want the midpoint of that line. So I'm looking for that point right about there. So I have the points. A is at 8x, 8y, B is at 8m, 8y, C is at 8q, 0, and D is at 0, 0. So the origin there. Well, the first point to get would be, I'm just going to choose my y value. So I'm going to go up from the bottom there. Well, I know if I go all the way up, I'm going to get to my y values here of 8y. So if I want the midpoint of that, or the location of the mid-segment, it'd be half of that. So half of 8y would just be 4y. Now, the second part is to get my x value, and that's a little bit harder because I know the distance here is 8x. I know the distance here is 8m, and I know the distance down at the bottom is 8q. And part of finding the mid-segment is adding my two bases together and dividing it by 2. So if I add all those up, so I got 8x plus 8m plus 8q, and divide all that by 2, I'd end up with 4x plus 4m plus 4q. And that line there would actually, the length of that line would actually be there. And we want the midpoint for that line. So we would again have to divide that by 2 to get 2x plus 2m plus 2q for our x value. And then our y there was still 4y. Didn't have room. All that would go up there. So that's how you find the midpoint of the mid-segment. Alright, now we need to find the lengths of the diagonals of this trapezoid. So let's draw in those diagonals. I'll do one in white and one in red, so you can kind of see the difference. So to find those lengths, I can think of that right triangle there in white. So the top leg would be P. So if I put this into my Pythagorean theorem, P squared would be part of it. And then the length on the bottom would be, I would have this length right here is M, and this one is N. So it would be M plus N squared. If I do my red one there, draw that in. Again, my height there is P. Oh, I forgot my plus symbol on the first one. M plus N squared. There we go. Plus P squared. So the second one, again, I got P squared for my height. For the bottom, I have negative M plus N. Well, these are distances, so you can drop those negatives. I did that on the first one and didn't quite explain that. But you can drop those negatives because it's distance, so it would be M plus N squared. So you notice I got the same equation for both of those. Alright, so now we need to prove the diagonals of a square are congruent. So I'm saying MO and NP are the diagonals of square MNOP. So what am I given here? I'm giving you that MO and NP are the diagonals of square MNOP. And what I need to prove here is that MO is congruent to NP. So since it's a square, I can just make up some variables here. So let's say O is located at, we'll just say S, comma 0. That would mean M is at 0, comma S. And N would be at S, comma S. So I just picked a variable. So if it's a square, those have to be the lengths because all the lengths have to be the same. So if you put this into the formula, or distance formula here, which is just a simplified version of Pythagorean theorem, so MO would be S squared plus 0 squared, so it would just be S squared, plus another S squared. Well, S squared plus S squared would give us 2S squared. So we'd have the square root of 2S squared, and we can simplify that because the square root of S squared would just be S, so we'd have S square roots of 2. And that was for MO. If I want to do PN, or NP, that's the way I named it, let's keep that consistent. Again, if I look at NP, the bottom one is S0, so S plus 0, S squared plus 0 squared is still just going to be S squared. And then my height here would be, again, S squared. So then I would end up with 2S squared, square rooted. Square root of S squared is S, so I'd get S square roots of 2. So those are equal. So I just proved that MO is congruent to NP. They both equal S square roots of 2.